in volumes. Once that law has been done, we are going to move to the next chapter, which is the periodic properties, like periodic table and the property of element, classification of element we are going to see. Fine. Okay. See now what is given in this chapter. These are the few last terms in this chapter which are quite important. I'll just explain this once again, last time. Law of reciprocal motion. This law is proposed by the Richard. Already, I yesterday gave you name, right? Richard is the name of scientist. So, what is the statement for this law? It stated that when two different elements combine with the same quantity of the third element, the ratio which they do so will be the same or a simple multiple of the proportion in the way they unite with each other. In a simple way to understand, they have A and B, right? A and B are the two elements combined with one another, and it can be combined with another third element, that is C. Okay. So the way how A is combined with C, the way how B is combined with C, in same manner A and B will combine with each other. For example, suppose A and C will be combined with each other like B and B will be with each other, that will be A to understand in same ratio, or maybe in a same multiple ratio, right? Because we know that 1 by 2 is equal to what? 4 by 8. 8 by same manner. These are multiple ratios of the same thing. If you simplify, we get 1 as to 2 only in this case. Right? And to understand, they have given us an example of carbon dioxide and methane molecule, and how water molecule is being formed, that is also given to us. Correct? Yes or no? Hello? Am I audible?
Yes, ma'am.
Yes.
Hello.
Okay, am I audible now?
Yes, ma'am.
Fine. Actually, I was asking you, did you understood this law or not?
Yes, ma'am.
Fine. What happened? I got disconnected or both of you got disconnected? What happened?
You got disconnected.
Okay, fine. No issues. See the next law which you have to learn. That is what? Gay-Lussac law of combining volumes. What is the law? Gay-Lussac law of combining volumes. In that, you should know who proposed law first. The name of scientist is Gay-Lussac. Okay. The name of scientist is Gay-Lussac. It's visible now.
No.
Yeah. No.
No.
Still it's not visible, beta.
Now it's visible.
Okay. So the statement for the law is under similar condition of temperature and pressure. See, under similar conditions of temperature and pressure, when gases equally combine, they bear a simple ratio in their volumes. See this one. The law stated that under similar conditions of temperature and pressure, when gases chemically combine, they bear a simple ratio in their volume. Suppose hydrogen and oxygen, they chemically combine to form, suppose, water molecule, right? So their volume would be in a simple ratio if temperature and pressure is what? Same or remains constant. Okay? This is a basic law and it's very easy. There is no
Can you
need
repeat
any
it?
sort of explanation in this, I guess.
Ma'am, can
If
you
you
repeat it?
want to write down this, please note it down. Sorry?
Can you repeat it? Can you
Sorry, I'm
repeat
not
it?
getting you. Will you please
Can
text
you
me?
repeat it?
Yeah?
Repeat it.
Okay, repeat. Fine, no issues. What it has been said, the law stated that under similar condition of temperature and pressure, when gases chemically combine, they bear a simple ratio in their volumes. Suppose you take a 20 ml of hydrogen and how much? 10 ml of oxygen. Right? Temperature and pressure is same. They have a simple ratio in their volume 20. That is equal to how much? 2 as to 1. Correct? Yes
Yeah,
or
one
no?
is to two.
In this way.
Yeah.
And this is called Gay-Lussac law of combining volumes. Volume would be in a simple ratio when your temperature and pressure of the reaction of gases would be same or remain constant. Understood? Yes?
Yes, ma'am.
Speak that. Fine. So this was the last law from your chapter.
Bye.
Now I'm going to share you another screen for the new chapter. That is what?
Oxidation and reduction.
No, not oxidation. This will be as other periodic periodicity, classification of element, and periodic properties. These points we are going to see. So first of all, you should tell me how many elements you are knowing till the
One,
date.
118.
Sorry,
118.
118. Okay, so you are knowing 118 elements. Fine, very good. And any other thing which you know? Uh, how we have classified it, because in 10th grade chapter was there, but it was deleted from your portion, I guess, and because of that you might have not learned it. Correct?
Yes, ma'am.
Yes. So for
Yes.
the curiosity, any of you read, like what is given in this and deleted from the chapter, though it is present in your book, have you took a space to read it once? Nobody. Hmm. Okay, tell me, how many of you took to read your grade? Just give me a while, okay? Just give me a while. Net issue is.
Hello.
Yes, I'm there. Don't worry. Just give me a while. Just give me a while. Clearly. Hello.
Yes, ma'am.
Hello.
Yes, ma'am.
You're audible.
Students. Now yeah. Fine.
But
So
your voice is
we know that till the date how many? Yeah. Am I audible?
breaking, ma'am.
Green. Okay. Till it is breaking.
It's very
Till
less.
my voice is breaking or not?
Yes, ma'am.
Audible.
it's better.
Is it audible, guys?
Now it's better.
Shall I continue?
Yes, ma'am.
Hello.
Yes, ma'am.
Yes.
Okay, fine. So till the date, we know there are how many 118 elements are present, right? As per the information you. Hello.
Yes, ma'am.
Yes, ma'am.
Still not audible or what?
Ma'am, now you're audible.
I need to. I think I have to extend the class, right? Because network is not working properly. Am I audible now?
Yes, ma'am.
Okay, fine. So as we know that there are means like 118 elements are known till the date, right? Yes or no?
Yes,
So
ma'am.
these elements have a different property, and each single element produce number of compounds, right? If you consider one carbon, you know that one carbon has a complete chemistry separate, like organic chemistry is made up by the carbon chemistry, right? Which there are number of several compounds are possible by made up by the carbon. Yes, and it is very difficult to classify them, and hence we need a perfect pattern to classify them on the basis of their properties, their physical appearance, their physical properties, and the chemical properties, right? So we need to classify them thoroughly on the basis of their what? Yes,
Physical and chemical properties.
physical and chemical
Chemical
properties.
properties.
Yes. Now, genesis of periodic classification is given in that. It's like how these classification begin, right? Earlier, there were hardly how many 20 to 25 elements. Later, we discover 63 elements. And currently, we know around 114 as per your book. And as per us, it's like every day, every year, new one or two elements have been born, right? Few are naturally occurred, few are man-made, right? So 118 elements are known, right? So genesis of periodic classification, in that what is given to you, see, check. A German chemist, the name of his John Doberner. See, this is the name of this chemist, Johann Doberner. In the early of 1800, was the first to consider the idea of trends among the properties of element. He tried to find out some trends in the properties of element. Okay, at his time, hardly what 63 or 53 elements were known. Okay, more elements were not there. But then too, he tried to find out some trends in those properties of the elements. In 1829, he noted a similarity among the physical and chemical properties of several groups of three elements. As it is a member, these groups are of three elements or three members are present in that group. It is called as what? Trades, right? You know that three is called as trio, right? And hence he named it as a trade. Three elements are present in the group, and name of this is trades. Trades. Okay. In each case, he noticed that the middle element of each of the triad had an atomic weight about halfway between the atomic weight of other two. Means if you have a three element A, B, and C, right? Suppose the atomic weight of A is X, for the B is Y, and for Z is, sorry, for C is Z. These are what? Atomic weights. right? See what I said. There are how many elements? 3 elements, A, B, and C. They have respectively atomic masses X, Y, and Z. When he arranged them in the increasing order of their atomic weights, what he found the atomic weight of the middle element, that is B, is equal to average of other 2 elements atomic weights. Means B is equal to X, atomic weight of B, that is nothing but a Y, is equal to X plus Z upon 2. Got it? Yes or no? This is called
Yes, ma'am.
as Doberner's trade. It is called as what? Doberner's trade. Once again, I'll repeat it. See,
Yes,
for your
ma'am.
understanding, what is this? Doberner's trades means? Yeah. What is the Doberner's trade? If there are the 3 elements group A, B, and C, and they have a respectively atomic masses X, Y, and Z, then the atomic mass of middle element would be equal to average or average sum of other 2 elements. Understanding? Means Y is equal to X plus Z upon 2. Means you have to take the other 2 elements average. Got it? And a real life example would be, here they have given, see, lithium, sodium, and potassium. Correct? Yes or no?
Yes, ma'am.
Atomic weight of lithium is what? 7. Atomic weight of sodium is what? 23. And atomic weight of potassium is what? 39. If you do this, like summation, as I said you, as per this, if they are arranged into the increasing order of the atomic mass, your sodium would be the middle member of the thread, right? So atomic mass of sodium is equal to how much? 7 plus 39 divided by 2. Come on, do this calculation. How much it would be?
46 by 2.
46 by 2, which
2.
is equal to how much?
23.
23. And this is what? Atomic mass of your sodium. Got it?
Yes, yes.
In the same way, you have to do for calcium, strontium, and barium. Then the chlorine, bromine, and iodine. Do it and let me know whether it matches or not within a minute. Hurry up. Can you do this?
Yes, yes.
Yeah, please go for it. In another thread, this calcium, strontium, and barium, your middle element is nothing but what? Strontium. So
But
atomic,
for the second one, it's 88.5.
so it's approximately correct. Yeah,
Yes.
near about, fine. Next one.
Yes, 1 minute.
For the strontium, what you will get over here?
81.7.
37 upon 2. Do this. You got 88.5 for this, right? Means it is approximately equal to 88. That is the
Then
atomic mass of strontium.
Then the second one, the last one is 81.7.
81.7. That is also approximate near to 80, right? Because few isotopes of bromine also have atomic mass 81 as well, right? Yes or no? So atomic mass of bromine is equal to 35.5 plus 127 upon 2. And now here 30.55 for the chlorine, but then chlorine may have the mass sometime 37, sometime 35. And in average, we are taking it as a 35.5, correct? And this is also can be affected into the bromine value when we calculate it in this way, right? But then these classification things have some certain limitation, because this can be followed by the certain pairs like this lithium, sodium, and potassium, calcium, strontium, barium, chlorine, bromine, iodine. There are the certain trades only available. All elements were known that time, were not able to follow these trades, right? And hence these are the limitation of these trades. Understood? Yes or no? Fine.
Yes.
So these limitations you have to keep it in your mind because all element does not follow these trades. Now what you have to do? you have to find out the new alternative for this, right? Even the scientists also try to do that in their like studies. And later we come to know about few new terms which we have to follow. Correct? See, law of trades are given. If you want to write it down, you can, because it's important for you. See, law of trade is given. That it seems to be work only for the few elements, right? It is work only for few elements. It was dismissed and as coincidence. The next reported attempt to classify the element was made by a French geologist, A.E.B. de Chancourtois, in the 1862. He arranged the known element in order to increasing atomic weights and made a cylindrical table of the element to display. Understand? But then his work was not known in that proper way, or it wasn't that famous, and hence cannot be considered later. Earlier, many of they have considered, but then later nobody considered it because it has also many limitations, and he arranged all the elements known in a cylindrical table. Understood? And he arranged all the elements in increasing atomic weights. Correct? Yes or no? Just keep it in
Yes,
your
ma'am.
mind the time period 1862 and the name of scientist. He is a geologist. Okay, French geologist. Name is A.E.B. de Chancourtois. Nobody will ask you question on it, but then too you should be aware of this. Hence, I'm going to explain it. Fine. Now, one of the important thing. Do you know about the music? All of you are aware about the music?
Yes.
Yeah. So what are the octaves present into the music? Tell me about it. Octaves of music, do you know or not?
No, no.
Don't know. So what you know about music? Only music I know. How about music? You know that the sa re ga ma pa, sa,
Yes, ma'am. Yeah, yeah, yeah.
re, ga,
Yeah, yeah,
ma,
yeah. We know. No.
pa, ha,
The
di,
Nisa.
the, ni.
Sa.
Okay, and then sa. If you see it, 1, 2, 3, 4, 5, 6, and 7, and then the 8. So what you come to know in this musical octave, sa is the first, and 8 is also again sa. Correct? Yes or no?
Yes, ma'am.
Yeah. So in this, what you have to keep it in your mind, like musical octave will repeat after 8 element, every 8 element, right? Like that. Newland was the scientist who arranged all the known element according to increase in their atomic masses or atomic weights, you can say, right? He found that every 8th element resemble the same characteristic properties with the first element. Understand how musical octave means like 8th octave would be similar to the first octave, right? In the same way, when we arrange the elements in increasing order of their atomic weights, every 8th element resembles same properties like that of the first one. Understood? Means these are also follow a musical octave rules, and hence it is called as Newland's octave. Why? Because John Alexander Newland in 1865, he propounded this law of octaves, and hence to honor him, we called it as a Newland's octave. But then these Newland's octaves are also limited up to calcium. After calcium, Newland's octave will not be work out. Understood? This is also limited up to what? Calcium. After calcium, we cannot utilize it. Fine. See what is given. The periodic reference of properties. See, the English chemist John Alexander Newlands in 1865 propounded the law of octaves. He arranged the elements in increasing order of their atomic weights and noted that every 8 element had properties similar to the first element. The relationship was just like every 8th note that resembles the first in an octave of music, like sa, re, ga, ma, pa, da, ni, sa, right? And hence, Newland's law of octave seems to be true only for few elements up to calcium. After calcium, it will not work. Although his idea was not widely accepted at that time, for his work, later he was awarded by the Davy Medal in the 1887 by the Royal Society of London. Fine. You just have to keep these awards and all in your mind. Nobody will ask you question about related to that, but then you should be aware about the laws of octave. What it is, when we arrange the elements according to increase in the atomic masses or the weight, every 8 element shows or resembles the same property that of the first one. Correct? Yes or no? Like a musical octave. And hence it is called as what? Newland's octave. Right? Yes?
Yes.
Fine. I hope all of you clear about it.
Yes,
Yeah?
ma'am.
Fine.
Yes, ma'am.
Now we are going to see few another important terms in this. We'll see this Newland's octave in a detailed manner. First. This is one of the important part of this chapter. First of all, we'll go for the Newland's octave. We'll check it first. Up to calcium only they've given. Are you able to see this chart? This chart. Yeah?
Yes.
Yeah. Started with here lithium, barium, boron, carbon, nitrogen, oxygen, fluorine. Then the sodium. Lithium and sodium have same property because it is from ion, this is also from +1 ion. Potassium also from +1 ion, because that their chemical property and the physical properties will be same, somewhat same, not exactly same, but then it will be same. It will be same. You can see barium +2, magnesium +2, calcium +2, correct? Yes?
Yes.
Yeah? Yeah. So if you see here, number 1, 5, 6, 7, and this is your 8th element. Means it resembles the same property like that of the first one. If you see the barium, if you consider barium as 1, 2, 3, 4, 6, 7, 8. Magnitude will be 8 of the barium, isn't it? Means every 8 element resembles next to that of the first.
Your voice is breaking.
Glands of it. Sorry?
Your voice was breaking. You're not able to understand.
I'm not able to hear you. Can
Your
you
voice
text me?
Your voice was breaking. You were not able to hear you.
My voice is breaking. Is it?
Yeah.
Am I audible now?
Before when you were
Am I audible
explaining,
clearly?
when you were explaining, it was not.
Still it is not.
Ma'am, in the middle, it's like little bit
Still
breaking.
my voice is not clear.
No, it's proper, ma'am. But
It's-
when you were explaining, it was
It's
breaking.
clear now?
It's
Okay,
breaking
okay.
in
I do
between.
understand. It's a network issue. I'll arrange something by today. Tomorrow, this problem would not occur. Okay?
Now, can you repeat that
Fine. I'll arrange
graph?
something. You're not able to see.
Can you repeat that graph?
Okay, okay, fine. Sure. I'll do that. Fine. It's not a graph, beta. It's a chat. Fine. I'll do that. Okay. See. Now here, lithium is your first element, right?
Yes, ma'am.
Yes? Yeah. If you count the element from lithium, this would be first, second, third, fourth, fifth, sixth, seventh. And the 8th element would be sodium again, right? Lithium is an electropositive element. It has a valency +1. Sodium also have valency +1. Lithium and sodium have same trends in their property because their valence electrons are same. One electron. Even potassium also have 1 electron, and hence its valency is +1. Correct? And as its valency is +1, they have same physical and chemical properties, or somewhat same physical and chemical properties. Same trends can be followed by barium, right? For the barium, 8th element would be what? 1. Barium would be the first. Then 2, 3, 4, 5, 6, 7, and magnesium would be 8. So barium and magnesium would
Ma'am,
show the
yeah.
same things. Understand? This is +2 and magnesium also +2. Even the calcium also +2. Understood now?
Your voice was
Hello?
still breaking.
Still it is breaking.
When you are explaining all, it's breaking.
Wait a minute. Am I audible clearly now?
Yes, ma'am. Now we are.
Fine. Okay. So now see here. Lithium is your first member. 1, 2, 3, 4, 5, 6, 7. And sodium is your 8th member. So first and 8th member show same properties. It has valency +1. This is also have valency +1. Even the potassium also have valency +1. Hence their physical and the chemical properties are same. They are resembling a same trends in their properties. Got it?
Yes, yes.
Okay. Now see the next. Now we are going to go for this barium. This is your first, second, third, fourth, fifth, sixth, seventh, and magnesium would be your 8th element. They have same valency +2, +2, +2, and hence they show the same trends. Understood? And they have arranged according to Newland's octave rule. 8th member shows the similar property to that of the first one. Understood?
Yes, ma'am.
Yeah. And same things can be applicable to each and every 8th member in up to calcium. Got it? Yeah. So boron and aluminum also have somewhat same properties. Then carbon and silicon, because their valency is 4. Nitrogen and phosphorus, oxygen and sulfur, fluorine and chlorine, because they are 8 to each other. 8th member. For the fluorine, you can see this is first, second, third, fourth, fifth, sixth, seventh, and fluorine is the 8th member. It is -1 charge. It has a -1 valency. Chlorine also have -1 valency. Got it? And hence they have same properties. Clear?
Yes, ma'am.
Yes, I hope you understand. Rest all, Dhananjay and Preetam. Understood or not?
Yes, ma'am.
Yes, ma'am.
Fine. And I'm extremely sorry for your I can actually I'm really very embarrassed because of this network. I'm extremely sorry for this whatever scenario has happened in the class today. 2-3 times I got disconnected. I'll fix it today anyhow, and the tomorrow this problem will not be occur. Okay,
Yes, yes.
fine. So the next part we have to learn about the Mendeleev's Mendeleev's periodic table. But then with Mendeleev, one more scientist was there. He also tried to put off the same efforts, but then he didn't become famous. Then yes, we have to learn about him as well, isn't it? So see what is given to you in this. Yeah. See here. The periodic law, as we know that today, owes its development to the Russian chemist Dmitry Mendeleev. What is the name of scientist? Dmitry Mendeleev. And his time period was 1834 to 1907. And the German chemist Lothar Meyer, and his time period was 1830 to 1895. So these are the two scientists who arrange all the elements known at that time in increasing order of their atomic mass or atomic weight. Okay. And once they do that, what they found? They found that there is a certain trends in their properties. And according to that, they have arranged all the elements. Fine. So these two scientists, they worked independently. Both the chemists in 1869 proposed that on arranging elements in the increasing order of atomic weights, similarities appear in the physical and the chemical properties at a regular interval. So Lothar Meyer is plotted a important thing related to physical properties only, like melting point, boiling point, etc. Correct? Yes or no? But then Mendeleev, he was the one who gave you all the details. Did you speak something in between?
No.
Hello?
No, ma'am.
Yeah. Lothar Meyer plotted the physical properties such as atomic volume, melting point, and the boiling point against atomic weight, and he obtained certain trends in the physical properties of element on the basis of arranging the elements in increasing order of atomic weights. Fine. See what is given to you in this. A periodically related pattern, unlike the new length, Lothar Meyer observed that a change in the length of that repeating pattern. By 1886, Lothar Meyer had developed a table. Okay. And what he done in that? Lothar Meyer made one table. Okay. And he arranged all the elements at that time by the increasing atomic weight. Fine. But then he didn't become famous because his work wasn't published earlier. Before him, another scientist, the name is Dmitry Mendeleev, the scientist who is generally credited with the development of the modern periodic table. We haven't gave any sort of credit to the Lothar Meyer, right? All credits is gone to whom? Dmitry Mendeleev, because there are the certain advantages of Dmitry Mendeleev's arrangements. What are those importance and the advantages that we are going to see into the next lecture definitely. But then he gave us periodic law, right? Dmitry Mendeleev gave us a periodic law. What is that periodic law? Right? First time. Before Dmitry Mendeleev, nobody gave us a periodic law for the classification of elements. He stated that the properties of elements are a periodic function of their atomic weights. Please note it down. It's quite important. The properties of elements are a periodic function of their atomic weights. Fine? Please note it down.
Yes, ma'am.
Okay? Fine. In the next period, I'll continue with this, all the terms. Like why Mendeleev's periodic table is very important, why we have to study, how many elements were present in that. Apart from that, what are the advantages and the disadvantages of Mendeleev's periodic table? And we are going to see its table also. Okay? Fine?
Yes, ma'am.
Fine. So
Yes,
till that
ma'am.
time, I'll take your leave and I'll fix the problem of my internet. Okay?
Okay, ma'am.
Yeah. Thank you.